Now in this video, let's go with the mathematical analysis of common emitter transistor in a common emitter configuration. When we have voltage as a sinusoidal wave in the common emitter mode. So, as we rightly know from the previous video that we have a transistor in common emitter mode, and we have a signal that we are using at the input of this common emitter circuit at the base of this transistor, and we have drawn its equivalent circuits. Now, if we start with the two linear equations, the equation in terms of voltage and the equations in terms of current. So what we have is we have VB, okay, that's V1 in that case, that is HIE plus HRE VC, okay. So C is here for V2 and B is here for V1. So this is the base voltage and here it is collector voltage, because we are considering this transistor in common emitter mode. So here IC, what will be IC? That will be HFE and IB, right? I think here I have missed something. This is IB, okay? The base current plus HOE, then we have the VC. Now, I will call this equation as equation 1, and I will call this as equation 2. Now, if we look back into this circuit, we can have two additional equations that we can write for the input circuit and for the output circuit. So what we will have this what's called as VB, the base voltage, right? The drop here, this base voltage will be what? It will be Vs minus IBRS, right? So base voltage, what will be that? That is VB will be equal to Vs, okay, signal voltage minus IBRS using KVL in this circuit, right? So this will be my another equation. I'll call this equation third, and then the output of this circuit will give me VC. Certainly, yeah, I can write this VC in terms of RL, and that will be minus ISRL. All right. Okay, so this is my equation 4, right? We have equation 1 for the voltages in terms of linear parameters. We have equation 2 for currents in terms of hybrid parameters in common configuration. Then we have VB for the input of this common emitter configuration, and VC for the common for the voltage, output voltage of this this common emitter configuration. Now, what I will start with is I think I'll go to the next page. What I will start with here is the current gain. Now, what is current gain? And I would like to symbolize it as AI. Since I'm using the common emitter configuration, so I will use AIE. Now, what is this current gain? So this AIE is what? What is it? It is basically the ratio between the output current to the input current, right? So we have to go with the output current. Now, what is the output current? That is IC. And what is the input current? That is IB. Okay, if you use the convention, so it will be minus IC by IB. Now, I have 1, 2, 3, 4. This I would call as equation 5, right? Now, I would like to put the value of equation 4, the equation 4 in equation second first, 4 in second. So putting 4 in second. Okay, so here I have VC. So what will be my collector current? That will be HFE IB plus HOE. Now this VC is what? It is minus ISRL. That should be the case, right? So from here, I can calculate IB. So this is HFEIB is IC. Okay, if you transfer this, this is plus HOE. Yeah, this is, yeah, what is this? This is HOE, HOE, and VC. Instead of VC, we are making use of this. We are making use of ISRL. Is it IS, or am I right here or wrong? Where's the... where is this? Yeah, where am I right now? IC is, okay, I'm putting 4 in 2. So what is my 4? Equation 4 is V, it is IC. Oh shit. When I use KVL here in this output circuit, here I will have IC. Okay, this is a mistake. Okay, take it away from here. So here it is IC. So this was confusing because I wanted to get IB alone. So this is IC here, and then we have RL. So this IB will be, IC will be out. So this is 1 plus HOE. RL will be with it, divide by HFE. So this will be my base current IB. Right? So now I can talk about this equation. So I can call this as equation 6. And I would like to use this 6 in equation 5. So I will call this page 3. So substituting 6 in 5. Okay, so AIC, current gain in, sorry, it is E, common emitter configuration. As I said before, as I said, my handwriting is bad, so these things do happen consistently with me. So instead of IC, I would like to write this equation. So this will be minus times, yeah, this will be minus times, yeah, instead of IB, I'll be using it. So this is minus IC is in the numerator, and for IB, I'm going to use IC. This times 1 plus HOE RL divide by HFE. I think this IC and IC will cancel from here. So what will we have? We will have AIE, the current gain. This will go up. So this is minus HFE divided by 1 plus HOE RL. So this will give me the current gain. This equation is going to give me current gain, and I can make some approximations here, like if I assume this RL, the load resistance, is very small than this HOE, right? Then this what's going to happen in that case is my current gain in that case will simply be minus HFE, and this HFE is symbolized as beta, so this is minus beta. So AIE will be minus current gain. All right, so this approximation we have used here. Now let us move on from here. and I must keep my previous things with me. So this is my page 2 and this is my page 3. Now what would I like to do is, you can see here we have the negative sign. So this negative sign is an indicative that the signal that we are going to obtain is out of phase. That means it's an indication of having transistor in common emitter configuration. As we understand that if a transistor is in common emitter configuration, we are going to change the phase of that signal. Now, the next important thing is input resistance. We want to calculate the expression for input resistance. Now, in order to do that, I would like to call that RIE. I think it is clear to you why I'm taking it as RIE. And this must be the ratio between base voltage divided by base current. This should be the case for common emitter configuration. The ratio between base voltage and base current. Now, if we go back to equation 1, where is that? This is, if I go back to equation 1, where is that equation? Yeah, here is it. I have, so if I write here from equation 1, so what's my equation 1? That is VB. So what is VB? VB is, it is HIE, yeah, IB plus HRE, then VC. Okay, this is my my equation 1. Or if I see here, I can divide this equation by IB. What am I going to get? VB by IB is equal to HIE. This IB and IB will cancel, plus HRE VC divided by IB. This should be the case. Now, now let me use the equation 4 for VC here. Okay, I have this equation 4 here. I will use this here. Okay, so here I should write using equation 4 in above. Now, if I do that, what am I going to get is, I'm going to get what am I going to get is this VB by IB will be equal to HIE plus HRE. Now, instead of this VC, I will have ICRL. So this will become minus. This is minus HRE, ICRL, yeah, divided by IB. This should be the case, if I am not wrong. Yeah, that's correct. Up to this point, it's okay. Now, what I'm having here is HIE, HRE. It's okay. How would I define now RIE? This is my RIE, so I can write here RIE. This input resistance is HIE minus HRE ICRL by IB. Now this is because this RIE is VB by IB. Okay, so that's the case. Now, can I have anything more that I can think of here is that this HRE, right? What is this this HRE? That is another important thing to be considered at this point. Is that this RIE is HIE? That's okay. And then we have minus HRE, and here I have IC by IB. Now what is this? This is current gain. So this IC by IB is AI RIE that we have. So I can think of writing this equation. RIE is HIE minus HRE AIE, and then if we rightly go to the conventions, it was negative here. So if it was negative here, so here we are going to get it positive. So RL, right? So finally, we can be thinking of using, where is my the previous equations? This is 6 and okay. So here we can use for AIE. I have not numbered that equation for current gain. What is that? Finally, we got the equation for current gain. I think I have lost it. Yeah. Oh, that's this. Huh? Okay. That is this equation. That is IC by IB. That will be HFE by this thing. So we can be using the same thing here. So RIE is going to be HIE plus HRE. And see, if I use here IC by IB for current gain in common emitter configuration, so that is HFE ऊपर चला जाए, that will go upside, and we will have HRE HFE and RL divide by HRE is the original one here, then HFE RL, that's correct. This is 1 plus HOE. So this is the expression for input resistance of this transistor in common emitter configuration, in common emitter mode. So here what we have obtained is the input resistance. Now what should we proceed from here is this is my 5. Okay, I would like to go for voltage gain now. Voltage gain. Now, to symbolize it, it is A is the gain, V for voltage, and E for emitter. So how do we define this voltage gain? This voltage gain is basically the ratio between the collector voltage to the base voltage. That should be the case in common emitter configuration. That should be the way that we can think of. Now here, VC we can use for VC, right? We have already have this equation as in terms of equation number 2, I think. So we can use for VC here. So what we will get, this AVE will be minus ICRL by VB. So using that was I think equation number 4, right? Okay, so this will be this kind of thing, and we also have this what we call as this VB, right? This VB can be, we know what we know. We know that this RIE from its definition point of view is VB by IB. So I can use this thing here. What I will get is AVE is minus IC or L divided by VB. Okay, it's divided by VB. VB is RIEIB. This is this I can write in terms of RIE. This is RIE, then IB. Okay, let's see where we go from here. So we have we have the voltage gain in common emitter configuration up to this. Now let's go back. What can we use here is from equation number 5. I want to get that equation 5 back. Uh, I want to see that if, yeah, I have that for AIE is minus IC by IB. AIE is minus IC by IB. Now, if I use that here, if I use this equation 5, what am I going to get is, I'm going to get is, so what am I going to use here? I should directly write that. So using AIE equal to minus IC by IB. Okay, so here you can see this is minus IC by IB, and for minus IC by IB I'm going to use AIE, right? So where's my equation? So this AVE will be it will be I AIE AIE RL by RIE. So RL is here, divide by RIE. This should be the case, right? So this is my voltage gain in terms of current gain and load resistance and input resistance. Now, what should we do is that we have the value of RIE, and we can substitute that value that we have obtained for RIE in this equation. So here is that equation. I have not named it. Say this is A, so suppose this is B and this is C. So substituting B in C. Okay, so what am I going to get here is I'm going to get AVE. Yeah, what is this? Yeah, it is AIERL divide by, yeah, what's this? Yeah, here I can write simply HIE plus AIE HRERL. Okay, so if I divide the numerator and denominator by AIE, what am I going to get is RL divide by HIE by RL here, plus HRE RL. So I am dividing numerator by AIE and denominator by AIE. Okay, so here I have the expression for voltage gain. Okay, if I would like to move on from here, and I would like to use the expression for I have HIE here. Okay, yeah, this is RL by HIE RL plus HRE RL. Now what should I look for here is where am I? So this is HIE by RL. This is HIE by RL. So where is my equation, which I'm going to put here? I don't know, where is it gone? It's lost somewhere. Okay, so here what am I doing is that I would like to have this evolved, this RL, right? So if I evolve this HIE, here I have RL. Yeah, what's wrong? HIE. Here I have committed the mistake here. I'm dividing the numerator and denominator by AIE. So I want to get rid of AIE, and I'm writing something wrong. So here it must be AIE. So this was something that was confusing me. So here I have to use the expression of AIE that we have already calculated in some equations. So what I will use here is AV will give me RL divided by HIE. Now, what is AIE? That is already calculated. Yeah, that AIE is it is minus 1 minus HOE RL divided by HFE. Okay, that's correct. Then I will close it. This is plus HRERL. So here we have used the expression for AIE. So we have used expression for AIE. So we are going to have something here. So what we will get, so this is here you will have the LCM that HFE will go up, and then you will have RE, and what you are going to get here is minus HIE. Then you are going to have minus HIE, HOE, and RL. Then you will get plus HRE, HFE, then RL. This will be the case, and I can boil down this equation as AV is equal to minus HFERL divide by this HIE, HOE, HRE, HFE. I would note down this as del. Okay, so RL is common to both. So this is what is this? This is HIE. This HIE. Then I have plus del RL. Okay, so where this del is what? This del is HIE, HOE. It's a 2 by 2 2 by 2 determinant minus HRE and HFE. So this equation gives me the voltage gain of this configuration in terms of H parameters alone. You can see everything in the right hand side is in terms of H parameters. And finally, we will have the power gain. And finally, we will have the power gain. And that power gain is P. No, it should be in terms of P. No, it should be gain is A, then power in common emitter. So this power gain, APE, is it is collector. It has to be the product of voltage and current. So this is collector voltage, collector current divided by base voltage and base current. So what is it basically is the voltage gain AVE times the current gain, that is AIE. So both of these parameters are already calculated, and we can substitute the value of AVE and AIE, and we can have the final expression for the power gain as HFE square RL divided by 1 plus HOERL times HIE plus RL del. So this will be your assignment. You can do it. You can just use the equation of voltage gain and current gain, and finally you can obtain the equation of power gain of a transistor in common emitter configuration in terms of hybrid parameters. So have a nice time. Goodbye and good luck.